Here I'm talking about the Melling and Scott paper, trying to give you some ideas of what's important. You're going to start your analysis here at stage 1. Instead of homogenization, you have PPE. You should be able to describe your volume. It won't be liters, it'll be milliliters. You should be able to say how many total enzyme units. Right there, you calculated it. And you should have a specific activity, probably much higher than 7 units per milligram. You can start this. Recovery is how effective were your purification techniques at maintaining the enzyme activity. Did you lose some? So this will be an important consideration. Start with 100%. That's what this is. You won't have anything to say about these middle steps here, but then you did absorption and elution from DEAE Cefacel. So that would be something you can put in your table. You put a certain amount of enzyme on the column, not your entire sample. See, this Melling and Scott used everything they had. So you'll have to be clever enough to ratio it out and calculate what was your percentage recovery in the fractions that had activity. So if you put, for example, 50 units on and you got 30 units collected in your fractions, that's 60% recovery. I believe all of you calculated your specific activity, so you can put that in there and you look at the change. Melling and Scott in this multi-step process had a 40-fold increase in specific activity, which is good, but still far from the pure enzyme, which has 3,000 units per milligram. So this is still only 10%-ish beta-lactamase, 90% garbage proteins. I think the right thing for you to do is to A, tell the truth, perhaps have an additional column, say for the column units loaded, and then units recovered, right? Units recovered. Here's the second table that Melling and Scott provide. Once again, you see there's this recovery percent here that starts with 100% and ends at 85%. So pretty effective at maintaining the total enzyme. You may have some things to say that are similar to what they've done. For example, some of you have done gel filtration on Cefadex. Once again, you would want to make 2 columns here. You'd have to have enzyme loaded onto the column and then enzyme recovered. And it'll be a percentage. It should not be greater than 100%. It probably won't be as high as 89% that they got in their paper. So just tell the truth. And the Melling and Scott paper did the unfortunate thing of changing their way of expressing specific activity. No real reason they should have done this, but since this is 10 to the minus 2, this number here is actually 156. This is 433. This is 2,650. So you can see that in this step, there's a large increase in specific activity, about 6-fold. And so that is the gel filtration step. The Cefadex for them was very effective. So some of you may have done a chromatography on DEAE Cefacel where you changed the pH. The Melling and Scott did that as well. Both of these are at pH 7.0. The original on the previous page was done at pH 8.0. So if you did some pH experiments, you can report on that. Just keep your eye on what's important. The percent recovery is important. The specific activity is important. And you need to present data that is convincing. Don't just put a table out there and say, trust me. Show the data that allowed you to calculate specific activity. show the data that allowed you to calculate the percent recovery.